By far, our underlying channel assumptions were a little bit closer to reality, having channel errors causing bit flips and corrupted packets. However, we did not consider loss. In design of our RDT3, we assume that underlying channel can also cause lost packets. But the question is, how to detect loss? A timeout approach could be used for this, meaning that the sender waits for a reasonable amount of time for the acknowledgement of the sent packet. If it receives the ACK during this time, it means the packet and the ACK are both received and there was no loss. However, in the event that it does not receive the ACK during this time, it might mean that either the packet or the ACK are lost during transmission. However, there is a possibility that ACK is received after the timeout as well. This will cause retransmission that could be ignored using the sequence numbers. Let's take a look at the sender FSM in our RDT 3.0 with packet loss possibility. After receiving the call with the data from the upper layer, the sender makes the packet with the sequence number 0, sends it using UDT send, starts the timer, and transitions to this data waiting for acknowledgement. If the wait becomes too long and reaches the timeout of the sent packet, the same packet will be sent again and the timer is reset. While waiting for the acknowledgement for packet 0, if an acknowledgement packet is received and it is corrupt or has sequence number 1, it will be discarded. This process will repeat until there is a correct acknowledgement with expected ACK number 0. That will cause the transition to the next state and stopping the timer. The next state is the start of the same process for packet 1, which will begin with receiving the data from the upper layer and continuing the process similarly. If no loss happens in this process, the flow of data will be packet 0 from sender to receiver, followed by ACK 0 from receiver to sender, then same for packet 1, and the same process repeats as long as there is data to send with data packets sent every RTT. Now, let's say a loss happens in transmission of packet 1. The sender will not notice this until its timeout clock goes off. When the timeout happens, the sender resumes the process with sending the packet with sequence number 1 again. What if an ACK packet is lost? Loss of an acknowledgement will have the same effect of loss of packet at the sender side, which is the timeout and resending the packet when the timeout happens. At the receiver side, the story is different though. The receiver that has received an acknowledged packet 1 receives a duplicate packet 1. It has to send another acknowledgement for this packet without extracting its data and delivering it to the upper layer. After this, the same process will resume. Now, what if we do not have a packet loss, but a scenario of late acknowledgement? The acknowledgement, which has not been received before the timeout, will be received after the resend of the packet, which is within the timeline for the second packet's timer. This will set off the timer for the second packet, but the duplicate packet will still be received at the receiver side and acknowledged. There is no harm in this repeat, and the send acknowledgement will be safely ignored.